Welcome to the Future AI Society channel, where we're exploring questions related to adding common sense to artificial intelligence. Be sure to like and subscribe, and for more, get a free membership at futureaisociety.org and participate in our online meetings and software development. Today, I'd like to address the question, when will my computer have common sense? Almost everything that frustrates me about my computer is because it has no common sense. If it only did what I wanted, that would make it so much better. This video gives an overview of many topics, and you may wish to dive deeper with questions or comments, or a visit to our website. You can also download our free open source software and try it out for yourself. Exploring common sense fascinates me. It's not just about artificial intelligence, but it delves into how and why the human mind works. When will we be able to add common sense to artificial intelligence? Rather than simply saying it's going to be 5 years or 50 years or never, I want to explain my line of thinking so you can understand why it is that I think what I think. Here are the topics in this video. First, what is common sense? Then, what is the current state of artificial intelligence? Next, how is the human mind different? What's missing from today's AI? And I will outline 3 abilities common to every child, but missing from AI. Then we can address the question of how big a deal will it be to add these missing components? Finally, given that we can create such a system, what will the impacts be? My name is Charles Simon, and here's an overview of my experience. I've been working in the AI arena for decades, and in addition, I developed software for a commercial suite of neurological test instruments. This project gave me insight into how neurons and brains work. More recently, I founded the Future AI Society, which has periodic online conversations on the topics associated with these questions. If you'd like to join, it's free. And just a note, in order to make the presentation more efficient, let's use the term artificial common sense, or ACS. So, what is common sense? Here's a reasonable definition. Common sense is the ability to make effective use of ordinary, everyday, experiential knowledge in achieving ordinary, everyday practical goals. This definition came from the book Machines Like Us by Brockman and Levesque, which I highly recommend if you're interested in this topic. So a key thing to observe from this definition is that the human mind is really good at common sense. And AI is not, because the human mind evolved specifically for the purpose of survival. We can make the human mind play chess or read and write or do mathematics, but it evolved for the purpose of practical things like finding your way or knowing what's edible and what isn't. How to be safe and survive in a real-world environment. I contend that adult-level artificial common sense is not possible without child-level common sense. This is the reverse of how the AI world has evolved, where it tried to solve the hardest problems, and then we were surprised when the solutions to so-called easy problems didn't arrive spontaneously. When I was an undergraduate, most of the AI community assumed that if we built a system that would play an excellent game of chess, that emulating all other human activity would be trivial. That turned out to be a false assumption. Let's consider that every child knows fundamental things, like objects exist and they persist in a 3-dimensional world. Children understand the concept of cause and effect. You take an action and the environment responds to your action. Children understand the passage of time. They know that there is a now, and they remember things from a past, and they plan things for the future. Our AIs do none of these things. This can be summed up in Moravec's paradox, which I loosely paraphrase as, hard problems are easy, and easy problems are really hard. It turned out that we could create a system that could play chess at a grandmaster's level, but our AIs still don't understand the fundamentals of the world. Watch this little girl playing with blocks and consider all the things she knows. Blocks can be balanced on each other. She can plan by visualizing putting one thing on top of another. And she can set a goal to create a stack and be happy when she achieves the goal. She knows that more blocks exist in the box beside her even when she can't see them, and something that most robotic systems struggle with, she can pick up a randomly oriented object and then use it. The list of things that children can do that AI today cannot is lengthy, so let's look at how today's AI work. I'm going to talk about the two most prominent AI areas. The first is the artificial neural network. These can be thought of as using a very powerful statistical method to recognize patterns. You give the artificial network numerous examples, and it adapts its internal values and subsequently can recognize new data and categorize that new data on its own. Although really powerful, the neural network requires a vast training set and usually requires complete retraining in order to add new categories. The second hot area of artificial intelligence today is called generative AI. A typical example is ChatGPT. We can think of it as the greatest autocomplete system ever created. You give it some amount of input, and it generates output based on the input you gave it. As an example, you can give it a request that it write an 8th grade term paper on the fall of the Roman Empire, and the system will do that. It has been trained with trillions of examples of word sequences from the internet, so it can calculate the most likely words which come next after my request. It is amazing, but it does have its limitations. Some people have coined the term hallucination for instances where a generative AI seems to make up stuff. Why does a system occasionally decide to do this? The answer is that generative AI makes up everything. Because what it makes up is based on the vast data set of information gleaned from the internet or other sources, there is a high likelihood that what it outputs will be correct. But the AI has absolutely no concept of true or false information. It's just word likelihoods. Both of these AI types understand nothing because they don't work the way your brain works. I have an entire article series on the fundamental differences between AI and biological neurons, but in the interests of time, we'll skip that for now. But suffice to say that as long as AIs are working the way they currently do, they will never understand anything. They will get progressively better at the appearance of understanding, but they will never actually think. Here are 3 aspects of understanding, 3 things that humans do that AIs don't. I see these as fundamental and contend that a computer which cannot do these things will never be able to understand anything. It is my working hypothesis that a computer with these 3 abilities added will have true understanding, but that remains to be seen. First, your mind infers rules rather than remembering everything. When you've learned that Spot, Rover, and Fido are dogs, your mind recognizes their common attributes and makes these attributes of the generic abstract concept of dog. Now you not only recognize more dogs if you see them, but if I tell you that Rex is a dog, you immediately can have a mental image of Rex without any other information. Remembering rules is vastly more efficient than remembering reams of details. By remembering just a few rules, you can spell almost every word in the English language. Then you only need to remember the exceptions. In fact, when you remember somebody's face, you only need to remember the aspects that make that face unique. You don't have to remember that there are 2 eyes, a nose, and a mouth. Those are common to all faces. Remembering inferred rules and exceptions is likely the greatest data compression mechanism that exists in your mind. This GPT-created image illustrates not only the concept of inference, but also how GPT doesn't really relate images and text very well. While the lowercase m and n may look similar, their meanings are significantly different. Second, we humans understand what we understand because we have experienced the world with multiple senses. We understand about objects because we've touched them and seen them and heard them and smelled them and tasted them. We know about 3 dimensions because we've actually moved through a 3-dimensional environment and interacted with it. We understand what a point of view is, and when we move, how our point of view shifts while the objects around us don't move, although they may appear to. This observation means that artificial common sense will necessarily come out of robotics. Robotics are the only mechanisms that can sense the world, and it is incomprehensible to me that any system, either human or artificial, could understand the world without ever having experienced it. After an ACS has gained its understanding of the world, the robots are no longer as important. In the same way, if you cover your eyes, you still understand about vision and colors and 3-dimensionality. So after our ACSs understand, they can still be the massive static cloud-based computers we interact with today. They could be just like what you think ChatGPT should be. Thirdly, something we do all the time is we plan. We do this using an internal mental model of our surroundings. We can imagine what things will be like if we take a certain action before we take it, and we can evaluate those actions to decide whether they're a good idea before we do them. I'm not talking about complex plans. Humans are actually very bad at these, which is why we have pencils and papers and PowerPoint. I'm talking about very simple plans that we do all the time. Deciding what to do by imagining the outcome first. These 3 things can be added to AI within the next 5 years. Why do I think so? At the Future AI Society, we have already demoed them. We have the universal knowledge store that can do inference. We have already built Sally robotic pods that have multisensory experiences and create a mental model. And we have already built a system that can do planning in a small way. These 3 things can be added to AI. And as I said, my working hypothesis is that if you add these 3 things to AI, you will have created artificial common sense. But after we've added these 3 abilities, we'll see what improvements we've made, and we will have learned the next steps we need to take. If we add these abilities and create ACS, how human-like will it be? Let's think about the human mind in 2 areas: the behaviors it creates and its internal sensation. We will be able to emulate the behaviors, but will the ACS have an internal sensation? It's hard to tell. For example, you and I have an internal sensation related to the colors in this image. But are yours and mine the same? We assume so, that you perceive blue the same way I do, even in the face of knowledge that there are colorblind people whose internal sensations of these colors is necessarily different. We might assume that a completely colorblind person perceives these colors as shades of gray, but they might perceive them as shades of what I perceive as shades of blue. How would we know? I contend that having an internal mental model with some ability to plan is a necessary precursor to having any internal sensation at all. If this proves true, it has significant implications for our concepts of human consciousness and our ability to measure it. We know ACS will be different from human common sense because our common sense is based on our sensations and our needs. When we plan an action, we always do so in the context of our fundamental needs, like breathing and eating and sleeping and being warm and safe. None of these needs makes any sense for an ACS. What would an ACS need? We can select and program in whatever we think would be best, perhaps being truthful or helpful. The people who create the ACS will decide what the fundamental goals are. If they decide that the ACS goals are to maximize profits, we will end up with entirely different ACS. So my concern is not so much with a future ACS itself, but with the people who own or create them. I'd like to address the science fiction idea that humans and computers are necessarily in conflict. This makes a great story, but it doesn't need to be the case. When we humans are in conflict with each other, it's usually because you have something that I want. Now consider the ACS. What will we have that the ACS wants? Not much. On the other hand, the ACS may have lots of things that we want. We'll see how we handle that. What about jobs? ACS will eliminate jobs. Technological advances have always changed the employment picture. The difference this time will be that the jobs that will be affected will be thinking kinds of jobs, white-collar jobs, attorney jobs, editor and writer jobs, accounting jobs, programming jobs. This is an aspect that we haven't addressed before. We need to focus on what we humans might do instead, and how we can leverage having computers that are smarter than us. Another question that comes up frequently concerns the immense energy requirements needed for today's AI. These won't be needed for ACS because of the efficiencies I mentioned. Bear in mind that I have a similar common sense mechanism in my brain that runs on only 12 watts of energy. This is proof positive that the megawatts used by today's AI are because of its approach, not because of the outcome it creates. So to sum up, ACS will make computers better because they will be able to understand you and do what you want and expect. Because of this huge advantage, ACS is inevitable. We have choices about how and where and what it might do, but it will happen. And shortly thereafter, with the normal progression of technology, superhuman ACS will exist too. Although robots are fundamental for ACS development, they may not be as paramount as is depicted in most images from science fiction. ACS will be different from human common sense because they will be based on different goals and different sensations. They will have different basic values because ours have evolved for survival, and they mostly make no sense for an ACS. The danger from ACS has been overstated by science fiction, but the impact will be huge regardless. We need to be thinking seriously about how we will approach our relationship with artificial common sense. If you've made it this far, you're clearly interested, so be sure to support more videos on this topic with a like and subscribe. Then visit the FutureAISociety.org website, join for free, and participate in our video conversations and get our open source software. I look forward to working with you directly, and as always, thanks for watching.